Right, good morning, everyone. Hope you're up bright and early this morning studying science. What we're doing here, anyways, is we're looking here at the homework on predicting formulas from Sparkling Science. Question 8 and question 9, there was very little difficulty with that. Just a highlight there for maybe those who weren't sure how to answer these. The chemical conventions for writing a compound, especially a two-letter element like we'll say iron, is that you always write it with a capital F and a small e. Okay, and that tells you it's an element. So FES, the mistake that the student made was that she wrote it as two capital letters and an S, so capital F, capital E, capital S, which would be incorrect. We don't represent elements that way. Okay, so that was the answer to that one. Question 9. The key info really that you can get from NH4 is that we have one nitrogen will bond with four hydrogens in a ratio of 1:4. This is because of the valencies, which work out as 4:4. Okay. Now, question 11, for the most part, you would have been able to answer that, except there is one problem. Part B, there's the rule that I gave you does not apply. Okay. And that's because we have a particular type of covalent bond, and I'll be looking at that. I'll leave that till last, and we'll talk about that one last. Okay. So, question 11a, anyway. In this question, we are asked to identify the compound. So, the compound is the chemical formula. So, you should have a chemical formula for each compound that's created. Like hydrochloric acid is given here, HCl. But you should also have a ratio, okay? A ratio for the number of atoms to in hydrochloric acid. So, the number of atoms of hydrogen is to chlorine. So when we work it out anyway, we can see that the valency of hydrogen is 1. Because it's in group 1, it's going to lose 1 electron. And chlorine is in group 7, so therefore it has a valency of 1 as well, because it can gain 1 electron. So therefore, what we can learn from this is that the ratio of valencies is 1:1. And also that means if the valencies is 1:1, that means that one hydrogen will definitely bond to one chlorine. So the actual ratio for the compound is also 1 hydrogen is to 1 chlorine. Okay, I'm going to skip B for the time being, and I'm going to move on to C. If we look here at C, we're told nitrogen is bonding with oxygen. Okay, so when we look at the valencies of these atoms, we can find that nitrogen is in group 5, so therefore it has a valency of 3. It needs 3 electrons. Oxygen is in group 6, so therefore it needs 2 electrons. It has a valency of 2. So when we work out this, we can see here that clearly the ratio is incorrect, or is like not matching, okay? And if we're going to follow this method, we would want to have the same ratio of valencies on the left is to the right, okay? So what we must do here is basically bond 2 nitrogen with, so 3 multiplied by 2 gives us 6, and 2 multiplied by 3 gives us 6. So in other words, 3 oxygen will match up there. Now, so this method works here again in that when we work it out, 2 nitrogen will bond with 3 oxygen, and they'll have a valency there of 6:6. So the actual compound here is N2O3. And the answer then in terms of the ratio is 2 nitrogen is to 3 oxygen. Okay, so 2 nitrogen is to 3, so it's 2:3. Okay, that was a tough one. Again, I don't expect you'll ever see anything like that at junior cert level though. Right, Mg plus O, again we can see the valencies straight away are even, so we have 2:2, we can bond them straight away. MgO is the answer there, and the ratio would be 1:1. Okay, so this represents the valency ratio, but the actual final answer ratio you're supposed to give is the number of atoms in the compound. So 1 magnesium is to 1 oxygen. On to E, we have N plus H. So nitrogen is in group 5, so therefore it has 3 electrons that it needs. Okay, so the valency is 3. Hydrogen is in group 1, it has a valency of 1. 3:1. So we can see here that if we want to create a ratio here that would match, we would have a compound here which has 3 hydrogen to match. Okay, the valency here of 3. In other words, the ratio for this compound is 1:3. Okay, 1 nitrogen is to 3 a hydrogen. Okay, I hope this is not confusing you. This ratio here, this is the valency ratio. Okay, so the valency ratio is how we work out the compound, and then you write down the compound ratio then in terms of atoms. So 1 nitrogen is to 3 hydrogen. Right, calcium plus chlorine. So calcium is in group 2, it has a valency of 2. Chlorine is in group 7, it has a valency of 1, needs to get 1 electron. So again, we can see this is quite an easy one again. To balance out this ratio, I need this to become a 2, so therefore chlorine is Cl2. Okay, so it's CaCl2, and again, if I was to write out a ratio of this, it'd be 1 calcium is to 2 chlorine. So 1 Ca is to 2 Cl. G. Last one, G, or no, second last one, C plus O. Okay, so C plus O here, we can see carbon is in group 4, so therefore it has a valency of 4. Oxygen is in group 6, therefore it has a valency of 2. We need to get this to become 4, so therefore if I have two oxygen, that'll become 4. So 4 is to 4, and therefore my compound is CO2. Again, for this one, the ratio, the answer would be 1C is to 2O, as in 1 carbon is, so 1 is to 2, 1 carbon is to 2 oxygen. That leads us on to H, and this one's straightforward, K plus Br. Valency is 1 in both cases, so therefore it bonds to create KBr. Okay, back to part B, and let's see why this is a problem. Okay, so we can see here, as I said, that the atoms in the periodic table won't always follow the rules that you have designed. Okay, so what I've given you there is quite a simple rule to work out the compounds that you would expect. You can expect that this would work for many atoms of the periodic table, but it won't work for all. Okay, especially atoms in the groups 3 and 4, there will be exceptions. So you can see here boron is in group 5, so therefore it needs to lose 3 electrons. And no, is it group 5? No, it's in group 3. So it's in group 3, so therefore it's going to definitely lose 3 electrons if you follow this rule. And carbon is a valency of 4, so therefore it needs to gain or lose electrons. Okay. So the ratio there is 3:4. Now, unfortunately, if we try to work this out and found the lowest common denominator, which would be 12, for B4 is to C3, there's no such compound. Okay, so I'm going to get out of this now and show you how to work this one out. Okay, this is, if any of you are choosing Leaving Cert Chemistry, would be the way you would represent compounds. Okay. I really this you don't need to worry too much about this rule, because you're not going to find this example at junior cert level. It just wouldn't happen. But what we can see here anyways is the following. Carbon, if you recall from what I had there a while ago, has a valency of 4, so therefore has 4 electrons that it needs to lose or gain. Boron has a valency of 3. Okay, so what's going to happen here actually is carbon is going to share 1 electron, and this line here represents a bond. So this line here is a bond. So carbon is going to share 1 electron here with boron. Okay, this boron. So therefore boron now has only got 2 electrons left. Okay. Carbon is going to share 1 electron here with boron as well, so therefore this was down to 2 as well. This is down to 2, this is down to 2. So there's 2 electrons left. And you can see here carbon here has used up its 4 electrons. 1, 2, 3, 4. It has used them up in this bond. Okay. The next thing then is we have 2 remaining electrons here. So therefore those 2 remaining electrons, you need 2 electrons to create a bond. Okay, so therefore these 2 electrons are going to be used to create this bond, these 2 electrons are going to be used to create this bond, these 2 electrons this bond, and these 2 electrons this bond. Okay, that might sound awfully complicated. If you don't get it, don't worry about it. It's not necessary at junior cert level. Okay, look, that's the corrections on the homework. And we're going to continue with I think we're going to continue astronomy now actually. So I'll talk to you later.